This video covers 3 topics: what is a case, how we choose what cases to study, and how that can bias the results of our research. To begin with, what is a case? Like variable, this is one of the harder research terms to define. A case can be an event, like an election, a geographic unit, like a state or a country. It can be a period of time, a specific social movement, or a piece of legislation. No matter what, it is the fundamental unit that you are trying to study. This is also a word that is typically used in 2 different ways in political science. Sometimes we mean case as observation, the unit of analysis in statistical research. But in qualitative research, historical analysis, and other fields like business, case tends to refer to a case study, which is a combination of observations about an event or policy or whatever that tell a story about what you're trying to research. In general, when I'm talking about statistics, I will use the word observation. And when I say something like comparing cases, I'm talking about qualitative or experimental analysis of a handful of things. So how do you decide what cases or observations to include in a study? Your level of analysis really depends on your individual project. You need to look at your outcome, that's your dependent variable, and see where there is the most variation. For example, if you want to study variation in the minimum voting age, you could look at differences across states. There your unit of analysis would be state. You could look at differences over time in the federal voting age, and here your unit of analysis would be year. Or you could compare laws in different countries, and then your unit of analysis would be country. The one that you choose depends on what question you're asking. I recommend choosing the one that is of greatest interest, the one you'll be able to get the most information on, or the one where there's the greatest variation. As you are making this decision, you need to take 2 things into consideration. First, how many cases or observations do you want to study? If you are doing qualitative or historical research, you typically do not choose more than 4 cases to study. By contrast, statistical analysis and surveys are best done with at least 100 observations. In some cases, you want to study all of the cases or observations. This is called a census. And sometimes, if you're just trying to identify initial correlations or are dealing with very large systems, like weather, you might want tens or hundreds of thousands of pieces of data. This is what we mean by big data. The second key question is, which cases or observations do you want to study? The most fundamental rule of thumb is that you need variation on the dependent variable. But beyond that, the cases you study will impact the results you get. So you want to choose the cases that are going to do the best job of showing a causal relationship that is generally applicable. Or, to use more formal terms, that maximizes internal and external validity. There are many techniques for this. Here I will review 3. The most common way to select cases, and the best to choose if you have large numbers of observations, is to take a representative sample. The best example of this is sampling a population for a survey. To accurately represent the views of a large group of people, you can randomly select respondents to ask questions to. If the way you choose survey participants is truly random, then your results will apply to the full population. Sometimes you don't have large numbers of observations, though. If you want to study major wars, there, fortunately, haven't been that many in modern history. At least, there haven't been the thousands you would need to choose a random sample. When you have small numbers of cases, the 2 most common strategies are controlled comparison or single case studies. Controlled comparison, also called most similar systems design, means that you take 2 cases that are similar across all the control variables you've identified, but that differ in the cause and effect. For example, I wrote my senior thesis on why there was ethnic conflict in Bosnia, but not Macedonia. These are 2 similar countries, both parts of the former Yugoslavia, so they shared a history, and both are ethnically diverse, which in the 1990s was the most common reason people cited for civil war. But we only saw civil war in one country, not the other. That leads us to look at the differences between the 2 countries. In this case, a federal political system in Bosnia, but a unitary system in Macedonia as the cause of conflict. Finally, if you only have the resources to study one case, then think through whether you want to study a typical case, the one that best demonstrates the causal relationship you're studying, or an outlier, a case that's different from all the others, so you can figure out what makes it different. Case selection is so important because it's one of the biggest sources of bias in research. When case selection goes wrong, it's called selection bias. The first problem is selecting on the dependent variable. Sometimes this just means forgetting to vary your outcome. If you want to study what causes ethnic conflict, but only look at cases where it happens, you're going to form the wrong conclusions. You might say that ethnic diversity causes conflict because all of your cases are, by definition, diverse. But there are plenty of diverse countries that haven't had civil wars. So without studying those negative cases, cases where the outcome didn't happen, you're going to identify the wrong causes. More often, though, you accidentally select on the dependent variable. For example, let's say you want to study the impact of taking accounting classes on your income. If you decide to study how many accounting classes MBA students take, which here is represented by the dotted line, you're going to bias your research. The thing is that MBA grads already make a lot of money, even without having studied accounting. So taking additional accounting classes doesn't make much of a difference. But if you look at everyone working in a company, you can see a much larger effect, the solid line. So by limiting the range of cases you looked at, in this case only looking at high incomes rather than all incomes, you didn't see a causal effect where there was one. The second problem is selecting on the independent variable, which we usually just call a selection effect. This is very easy to get wrong and can show you causal relationships that don't exist at all. For example, let's say you want to study the impact of labor law on economic growth. If you study the effect of repressing labor looking only at cases from Southeast Asia, you're going to see a relationship that looks like the graph on the left. The countries that repress labor the most achieve the highest levels of growth. But if you look at all developing countries over the same time period, you get the graph on the right. You can see that there's no relationship between labor repression and economic growth. So in this case, the problem with limiting what you look at is that unless you do it well, you accidentally rule out some causes and overemphasize others. There are many types of selection effect beyond sampling bias, which is what we just discussed. Sometimes the bias isn't obvious or is the result of a decision made by the researcher. For example, there might be attrition in cases. Sometimes not all research subjects survive. This matters in longitudinal studies. Those examine the change over time, such as one of the surveys done as part of the American National Election Study. That particular survey interviews the same people every few years to see how and whether their political behavior changes. But people die, and if people with certain opinions tend to die earlier than others, mortality rates are higher in the South, for example, your results will become more and more biased with every survey. Survivorship doesn't just apply to people. In international relations, an important source of bias is state survival. There are many more countries in Europe today than there were in 1900. So if you want to study the results of war or state capacity, you have to consider that it may be only the strong states that actually survive, and that we're looking at a biased sample just due to history. The last two types of selection bias I want to talk about both relate to why people choose to participate in a study. Non-response bias is a bias that emerges when certain types of people choose not to answer survey questions or participate in a medical trial. There are many reasons why the polling in advance of the 2016 elections was a bit misleading, but one contributing factor is that very few people respond to opinion polls, and Republicans are less likely to fill out a poll than Democrats. When a key group is underrepresented in a survey, it's hard to predict how they're going to vote. The last type of bias is very similar. It's called volunteer bias, and it's very common in internet polls. When absolutely anyone can choose to participate in a survey, only people who are really invested in a topic, or, as in the case of a British survey on what to name a research sub, people who find an answer funny. Volunteer bias also comes up in other ways. If you want to study the psychology of people who run for president, for example, you need to realize that standard psychological studies may not apply. People who run for president are different from the average American. They might be more ambitious, more educated, more risk acceptant. There are lots of potential differences. So you can select into leadership just like you select into answering a poll. At the end of the day then, external validity is about how good a job you did at case selection. Did the cases or observations you chose to include in your study actually represent the universe of cases you are interested in? If yes, then you are more likely to have internal validity because you are more likely to have identified a cause, and you have the potential to have external validity. because there are two questions you ask about external validity. One is the representativeness of your research, and the other is extrapolation. Can the conclusions you draw from your study apply to other situations? For example, if you study a representative group of Americans, you may be able to draw conclusions about the entire US population. But if you study Bosnia and Macedonia for your research on civil war, do those conclusions apply to other countries too? Under what conditions might they be relevant? These are the questions you need to ask about external validity.